Good morning, everyone. My name is Keith Cordero. I'm studying mechanical engineering at the Illinois Institute of Technology, and I worked at Plant Chicago over the summer. John Mulrow is the interim director of the Plant Chicago. He's here with me today. Before we start, I just want to give an overview of what I'm going to be talking about. So I'm going to give an overview of Plant Chicago and who they are, what their mission is. Talk about zero net energy system. So as far as closing loops, which is a term that I had never heard of before starting, so we'll talk about that. Anaerobic digester, that's another thing I didn't know. When I found out I was being placed here, I did some research on anaerobic digestion, and pretty interesting. We'll talk about that. Some of the things I worked on too was a light audit. So I went around to all over the building and kind of inspected their lights and made recommendations as far as what could be changed out. Energy audit, we'll talk about that. Rainwater capture, that's an interesting project. Repurposing waste streams, which is a mission of not only Plant Chicago, but the building itself. And special projects that I worked on, we'll get into that. So what is the plant? So the plant is a 94,000 square foot facility. They're originally a meatpacking plant. Located in the back of the yards neighborhood. So if you're unfamiliar with the back of the yards neighborhood, or if you've ever read the book The Jungle by Upton Sinclair, it actually takes place in the back of the yards neighborhood. And so back in the 1800s, early 1900s, back of the yards neighborhood was the center of the nation's meatpacking. So everything was processed there and shipped out throughout the country. This particular building was owned by Pure Foods. And what they did there was they processed pork. And this building was in operation from 1925 to 2007. At that point in time, Pure Foods actually relocated to Indiana. So this building was vacant. And there was a man by the name of John Adel who, through his company Bubbly Dynamics, purchased the building. He had already purchased another building similar to this. I believe it was a paint warehouse, and they turned it into like an artist studio. I think there's like a glass blower there and different artists or whatnot. So his vision for this building, instead of being an artist studio, is to be more of a food processing facility. And a lot of this, it made sense because this was an old food packing plant. So instead of tearing the building down, which was what was originally there, put it on the market in hopes someone would buy it, strip out all the materials, sell it, and just tear down the building, demolish it, and put up, a commercial space or whatnot. He decided to keep the building, and he wanted to repurpose a lot of the materials within the building. So in addition, the plant is the name of the building itself, and within the plant there's about 15 different tenants, Plant Chicago being one of them. So what Plant Chicago, with their mission is it's to educate the community as far as closing waste loops. So what I mean by that is if someone's, just being able to repurpose stuff. So whether it's recycling it or putting it in the compost or maybe even to reuse it. I can see John there has an old paste salsa jar that he's using as a water jug. So that's an example there of repurposing materials. So that's what Plant Chicago is all about. So in addition to Plant Chicago, some of the other tenants in the building are a bakery, cheese distributor, Kombucha Brewery. Anyone familiar with Kombucha? Besides John. I didn't know either. Do you know what it is? Oh, would you care to explain? Or?
It's a brewed drink, health drink.
Yeah. So yeah, it's tea. It's fermented. I think it's like 0.5% alcohol. I don't even think it's enough to be considered an alcoholic drink. But yeah, it has some of the bacteria that's in it is beneficial for the digestive system and whatnot. Aquaponics, space in there, a microgreens grower, honey farmer. There's farmers that occupy the lands in the back. Mushroom grower, coffee roaster, and which is moving in now, and a beer brewery, which is also moving in now. So, did I mention the shrimp grower? I guess I didn't put that one on there, but there's a shrimp farm also. So it's Salty Prawn. I think they have about 20,000 shrimp that they farm. And so they have it's all in these little like pools, and it's in the basement. So they raise the shrimp and sell it through different restaurants throughout the area. They also have chickens too. So in the back there, the lady who runs the Salty Prawn has chickens, and every now and then I guess a shrimp will jump out of the pool, so she'll feed the shrimp to the chicken. And there's different other stuff that I'll get into that get fed to the chickens too. I think the chickens probably produce about I think 24 eggs maybe a week, or 12 to 24. I'm not quite sure what the number's on that. And she sells them at farmers market, and she eats them too. I actually bought a dozen, and they were really good. Aquaponics. So this is another thing. Well, this was an education for me. I'd never heard of aquaponics either. And it's pretty interesting. So how it works is it's kind of a symbiosis with plants and fish. So they raise the fish in some tanks. I think this is one of them back there you can see. So there's fish in there. They have tilapia. They tend to be the hardiest fish. They're able to be packed in close together, and their tolerance is a lot higher than other fish. So the idea is, as the fish produce waste, whether it's solid or liquid, that gets filtered and processed, and it gets broken down. I think it's ammonia that gets broken down into nutrients that are piped into the water, and they actually grow plants with the nutrient-rich water from the waste of the fish. And they sell these plants at farmers market. And a lot of this, what Plant Chicago is an education. So what they do is they give numerous tours of the plant throughout the week. And what they're really trying to do is educate the public on closing loops within the economy. So a lot of the stuff that's at Plant Chicago, whether it's the aquaponics or whatnot, it's more of an education, so someone can understand what we're trying to do and what the mission is, and also maybe an education as far as how they can close waste loops within their own life. So this here too is part of Plant Chicago. What this is actually is with the shrimp farmer, that they take the waste from the shrimp and pipe it through. I don't have a picture of it because the lighting was kind of hard to get it, but there's a vat where all the shrimp waste gets pumped into, and it actually goes through all these tubes. So the water just kind of goes back and forth, up and down through all these tubes. And what they're doing here is they're growing algae in these tubes. So they're trying to close loops within the shrimp farmers' business, as far as taking the waste and converting into something else. So they take this shrimp, they grow the algae, and the idea is to capture that algae and feed the fish with it. So the bakery, this is kind of an overview of what they have. They have different. They do savory pies, so it's like steak and ale type of pies. They also do some muffins and cookies and stuff like that. So that's kind of. We'll talk a little bit more about Pleasant House Bakery, and they have a wood-fired brick oven. That was pretty interesting, that I based some of my project on. We'll talk about that. So the fruiting mushrooms is a mushroom grower within the facility. And here you can see there's, in the basement there, it's a humidified space. They call these things logs. So this is all these logs are, I don't know, maybe 5 feet long. And it's all filled with different type of growing medium, whether it's straw, sawdust, or whatnot. And through the process, they poke holes in the bag, and then these mushrooms just grow out of them. And they sell these too at the farmer's market too. It's pretty interesting. They grow pretty fast. Yeah, what they do with the straw is here. So another way of closing waste loops is they take this straw and they compost it. So all the waste that's in the facility, they try to whether recycle it or compost it as best they can. So you can see here, this is all the spent straw from the mushroom facility that gets sorted out. A lot of this too gets fed to the chickens, so there's still stuff in there that they nibble at. Great American Cheese is a cheese distributor, so they purchase cheese from a cheese farmer in whole log or wheels of cheese, and they cut them up into slices, and then they repackage them, repackage the different slices, and sell them out. Farm space. So in the back here, you can see there's a Patchwork Farms is what occupies the farm space in the back. So yeah, this is all, majority of it is their space here, and they grow and occupy that area. In the back here is a mural that was commissioned by an artist. What they decided to do is incorporate the original Pure Foods logo that was existing in the building, and create, it's more or less a nod to the history of the back of the yards neighborhood, so that it's kind of melding the past with the future. Bika Bee is a bee grower that's on the roof, so they have these bees in these chests here, and the bees will use the plants in the back to pollinate and to use to produce honey. I think the lady told me that they produce, I guess it depends on the season, but they produce anywhere from 50 to 500 pounds of honey per season. Kombucha, so these are some of the fermenting tanks for the kombucha tea. Yeah, so it's, I'd never had it before. I tried it, it was really good. It's like a carbonated beverage. Yeah, it's tea, but yeah, it's really tasty. Weiner Brewery, so these are some of the tanks that are being installed right now. I believe they'll be ready to brew in the fall, and they'll have finished beer in December. And it was a former employee of Goose Island that's starting this company. So what I mentioned earlier is Plant Chicago, really wants to, their mission is to really educate the public on circular economies. And they try to be present in the community as much as they can, whether it's attending different back of the yards meetings or whatnot. And one of the examples of their community outreach is they have a farmer's market. So every Saturday, excuse me, every Saturday there's various vendors that come out and to sell their products, and the idea is to get as many people from the back of the yards neighborhood as they can to attend, and also people from outside the neighborhood too. So that's actually a little plug. Next week they're having a monster food truck rally where 5 different food trucks are going to come out, and instead of the farmers market, they're going to have that food truck rally. So these are some of the different vendors that are there. Some people this is the house, so they sell their products there at the farmers market. You have some farmers here, with different vegetables, fruits and vegetables that show up. This is the Pleasant House. These are donuts and croissants that they sell. And the pizza, which is really good also. And this is the Back of the Yards festival. So Plant Chicago had a booth there, and what they were trying to do is just, again, try a different way of educating the public as far as outreaching to them, as far as what their mission is, and trying to create circular economies not only within the building but within the community itself. Another way is they go out to schools to teach them, and also schools come to the plant too to take tours and to volunteer at different projects too. So it's kind of a good way for them to get exposed to Plant Chicago's mission at an early age. Now, like I mentioned, public tours. So they give various public tours throughout the week, where we take a tour of the facility, of the plant's facilities, and they can see how we're trying to create a circular economy within the building. So what I mean by closing waste loops, so this is a diagram of ideally what they want to do is where everything is interrelated, where the brewing process, kombucha releases carbon dioxide, so the idea is to capture that carbon dioxide and use that to the plant so they can grow. I alluded to earlier with the fish, so then fish produce ammonia. They convert that into fertilizer that the plants can use to grow. The brewery too, there's going to be a lot of potential with the brewery. There's going to be a lot of waste there, spent grain and whatnot, that we can possibly look to compost or repurpose in different ways. I think the brewery or the bakery was interested in possibly compacting that spent grain into bricks to use to fire their brick oven. At the heart of all this waste is the anaerobic digester. So the idea with the anaerobic digester is to capture any type of organic material and put that into the digester to produce electricity. Let me go back. Yeah, so to produce electricity, which I'll get into in a couple slides. But yeah, so what I did is I spent some time with each of these tenants to get it was just more or less a crash course on their process, on their business, and get an understanding of what material is brought into the building, what do they process, what do they produce with that material, and what waste do they have as a result. So the plant does a really good job of trying to close waste loops, but they didn't have any type of metrics as far as, well, how much of this is being recycled, how much of this is being composted, and what is actually being thrown away and put into a landfill. So like I said, I sat down with all these tenants and just created an itemized list of what food they bring in, whether they throw away, whether it's latex gloves, syringes, or whatnot. So from this is an overview of what is being brought into the building. So, and also I took a look at the plant's utility statements. So I included the electricity in there because they wanted to know how much they're currently consuming in electricity, because the end goal is to use the digester to generate electricity within the building so they can be off the grid. So the building itself as a whole consumes about 65,000 kilowatt hours a month. They use about 67 gallons of water, 141,000 BTU. This is the amount of organic material that's being brought in, inorganic. So this is all going into the building. And this is what's coming out of the building. So all the tenants in here are on board as far as trying to recycle and compost as much as they can. So this is the amount. So about 58,000 pounds is being put into a landfill. 66,000 pounds a month is recycled. 184,000 is composted. And this is the amount of goods that's produced with those materials, whether it's the pies or the shrimp or whatnot. This down here is C&D material stock. So there was a lot of, as I mentioned, the owner of the building wants to repurpose as much of the building as he can. So he stripped out a lot of the building, and this material stock is bricks, glass blocks, scrap metal, or whatnot. So this is all still in their inventory. So I took account of that as far as what is being held as material stock. All right, so the brick oven. So this is a view of Pleasant House's brick oven.
Hey Keith, we got a question back here.
Oh, sure.
On the water, 67 gallons of water.
Oh, I'm sorry, it should be 67,000. Yeah, sorry. Yeah, my mistake. 67,000 gallons of water. Yeah. Sorry, typo, or I forgot to admit that. Yeah. So the brick oven here, they fire it twice a week, and it takes about a day for it to get up to temperature. So I think they get it up to about 800 degrees, something like that, and they use that for their baking for the day. And there's enough, once they're done for the day, there's enough residual heat because it's so well insulated that there's a lot of residual heat that's left over from the baking process. So what they do is they take the wood that they get and actually put it into the oven to kind of dry it out or to season it. And the wood that they actually get is from the Chicago Park District, majority of it is. So trees that are cut down from like the emerald ash borer or whatnot, they get a portion of that and they split into logs and they fire up the oven. So when I was talking with the bakery, they had mentioned that they use about 30 face cords of oak. So I did some calculations as far as, well, how many BTUs of heat is that? So it's about 720 million BTUs a year. And that some of that's getting absorbed into the bakery goods, but a lot of it's just going out through the flue, just heat that's just leaving the building. the owner of the building really is interested in trying to repurpose this heat. So he has he has a heat exchanger in place on the flue, but what he really wants to do is to use this to capture that heat, the exhaust heat, to heat water, and use that water within the building instead of a water heater. So if they did that, if they were able to capture that heat and to heat water instead of using natural gas, they'd reduce about 38 tons of CO2 emissions per year. So with this, speaking with the owner, he estimates it'd be about $1,000 to put in a heat exchanger and to heat water up throughout the building. So $1,000 investment, and that's about heating that amount of water would cost someone almost $6,300. So that's about, that's $6,300 in savings that they would have instead of using a water heater if they would use the heat from the flue to heat the water. Payback on that would be 0.15 years, so like a couple months. All right, so the digester, is anyone familiar with how an anaerobic digester works? A couple people, okay. So the idea is, this is the storage tank. This is one of them. They're gonna ideally install a second one. So this one can hold 15 tons of material, or process 15 tons of material. And if they had a second one, it would be able to process 30 tons of material a day. So the idea is to put food scraps in here. As the food scraps decompose, that produces methane. And what they want to do is capture that methane and pipe it into a gas turbine to produce electricity. Now the plant isn't going to be able to provide 30 tons of food scraps a day, so the idea is to contract with facilities throughout Chicago. Our calculations are, if this was running at full capacity, we would be processing about 2% of Chicago's food scraps. So that's just another way of closing waste loops, not only within the community, but also abroad in Chicago.
Are there any special permits that you would need in place to be able to utilize other waste coming into that?
Yeah, I'm not quite familiar with the process, but they would charge a lot of the companies, because in the back of the yards neighborhood, there's a lot of potential there. There's a fat rendering plant that's really close, and you can smell their processing. So, and they dump their stuff, I think, in a place in Indiana. So as far as permits, I'm not quite sure, but it would be a lot closer for them to just tip their stuff across the street as opposed to going to Indiana for it.
I can chime in and just say the world is hazy. The permitting world is hazy. This is the first digester that will be installed in the city. But the area is zoned as heavy industrial M32, which makes it, which kind of like is almost a blanket. You can do like all sorts of crazy things in an M32 facility. So they had to be M32 to install the digester, and then from there, the IEPA rules are a little bit unclear, but the city of Chicago's composting ordinance just made it easier as well to accept food scraps from on site. So they're expecting not to have any big permitting issues once it gets online.
Okay. So like I mentioned, 30 tons a day comes out to about 11,000 tons of food scraps per year. They would target fats and oils because those are going to tend to produce the most amount of methane. So once this gets piped through to the turbine, assuming a 40% efficiency, it produces about 4.3 megawatt hours of electricity per year. So that's enough electricity for about 250 homes. The other potential too is the exhaust on the gas turbine. They also want to capture that, use that heat not only they would use it to heat the digester itself, because the ideal operating temperature would be 98 Fahrenheit. So the idea is to capture that exhaust from the turbine, capture the heat, and use that heat to heat up water, and they would use that water to heat the tank itself. So that would take about, so that would expel about 22.4 million BTU. They would capture 14.6 of that to heat the digester. They'd have remaining 7.8 million BTU to be repurposed within the building as they see fit. So on that, these are just some numbers, kind of running low on time, but these are some of the numbers on it. So about 4.2 $1 investment to get this up and running. So the idea is to resell. They're not going to be able to use all this electricity, so they're going to resell a great portion of it back to the grid. And actually, it's going to be, with ComEd said they would pay 3 cents per kilowatt hour for their electricity. So that's kind of a shame. But this is how much revenue they would get from it. This is how much, if they were to heat the digester through natural gas, this is how much they would spend. So I would count this as savings. And at the end of the digestion process, not only is there methane, there's also solid digestate and liquid digestate. So the solid would be like compost, and liquid would be like a fertilizer. So they would sell that too. So these are some of the numbers on that. Tipping fees, which I alluded to with Rick, is that they would contract these people to come in. They would charge them not to deposit their material. There would be a lot closer for a lot of these facilities. So anticipated revenue would be about $324,000 for a total of $772,000 a year. So payback on this would be about 5.5 years. Yeah, so they would save 11,000 tons from landfill, and it would result in about 4,100 tons of reduced carbon dioxide emissions per year. This rainwater brine tank, so since it was a meat processing facility, this is a tank that it was a brine tank, so they would have salt water that they would use to cure their meats or whatnot. The idea behind this, the owner actually has piping from the roof to capture rainwater, and it's actually going into the tank now, but they don't have any plumbing in place to distribute that water throughout the building. So it's a 9,000 gallon tank. Based on the square footage of the roof, they would be able to potentially capture 170,000 gallons of water a year from that brine tank. The owner of the building estimates the project would cost about $1,400, and to use 170,000 gallons of water would cost somebody $565. So I'd count that as savings, water savings. So the payback on this project would be about 2.4 years. Light audit. So I went and examined the bulbs within the building. They're doing a really good job as far as they have a lot of T8s, LEDs, a significant number of LEDs, CFLs. They do have some T12s. So they have about 54 T12s that still need to be replaced. So this would be including changing the ballast and the bulbs. That would be the cost for that. ComEd will give them an incentive on that. I'm sorry, the numbers, I must have missed a one there, but yeah, that should be about, oh, I'm sorry, this is energy savings. If they were to change the T12s to T8s, this is what they would be saving in electricity. So the project, so I recommend keeping the T8s, replacing the T12s. They have some stock T12s that are just laying around. ComEd would give them $20 for the 300 bulbs that they have. And changing the exit signs to LED also. So this would be the total investment to replace all the bulbs, the incentive that ComEd would give them for that, the saving electricity savings. So the project would have a payback about 1.7 years. So if they did the recommendations, they'd save about 14,000 kilowatt hours, and that would reduce carbon dioxide emissions by 9.6 tons a year. Biobin, so in interest of time, I'll just go over this real quick, but what they're doing here is that all the organic material is being put into this bin, and oxygen is being pumped into it, and they're converting this into compost that they're using on site for potentially to sell or also to use in their farm space. Yeah, so the contractor, we have a person that was working on the biobin. What he told me is that contractor is going to deposit about 48 tons of food scraps per year into the bin, and they'll use that those food scraps to the process to turn into compost. Hand dryers, so within the building they use paper towels, there's no hand dryers. So these are just some estimates as far as what would a hand dryer cost. This is how much it would cost to use a hand dryer per year. This is how much they would save in paper towels if they used a hand dryer instead. So payback period on that would be 2.3 years. and it would result in about a 1/4 ton of reduced carbon dioxide emissions per year. Yeah, which I mentioned earlier, stock materials, so there's glass block, bricks, cinder blocks, scrap materials. This is all, they're trying to sell this off to contractors for new build outs. So right now, I did an audit of that. They have about approximately 217 tons of material there. And the value, if they were to sell it all off, would be approximately $98,000 in revenue if they were able to sell that off, which they're slowly selling off. This is an example of repurposing materials. So this is wood that they captured within the building, that they salvaged within the building. You can kind of see some of the timbers here. And they made this into a table that they're going to use in their farmers market space. This here are the old smokers. What they want to do with these smokers is convert these into bathrooms, whether it's like showers or toilets or whatnot. So that would be like their bathroom space within the building. Another way that they repurpose materials is aesthetically. So they had a sculptor come out and made a sculpture of some of the various rubble that was located within the building. Here's another one. This here is an old flash chiller. I guess it froze meat in a matter of seconds. They're going to use this space as office space. So the brewery is actually going to occupy this space, convert it into an office, and use this old chiller space as an office. This here is the farmers market stand, I believe. So this is another place within the building. They're going to convert into a room for like a indoor farmers market area. Special projects. So this is so the digester isn't up and running. So what we did was we kind of did a smaller version of it. This one here is we just put some waste into a bottle with some water, and we let it sit, and it slowly started inflating the balloon. So that's the methane that's being produced from the waste. We estimated about 5%. The bottle lost about, we weighed it before and after, and the bottle lost about 5% of its weight. So that was from the methane that was expelled from the solids. This is a larger scale one that we did. So this here is, I don't have any end results of this because this is new. But yeah, you put the waste in here, it goes into these tanks, and you capture the gas as it gets expelled will come out this tube. We attach the weather balloon to it. So this is where the methane will be captured. And this spigot down here is what's going to capture all the digestate. So unfortunately, I don't have any numbers on that because that's being done right now as we speak. Another thing we worked on was a professor of business at IIT contacted us because they wanted to use the plant as a case study for what she was doing. So I provided her with some of the numbers, and John and myself were listed as co-authors on this write-up, and she presented her findings at the International Society of Industrial Ecology Conference in the United Kingdom. So this is just an overview of everything, all the projects that I recommended, total investment and everything, savings that would result from the projects, about 4,200 tons of carbon dioxide emissions would be reduced as a result of implementing these recommendations. 170,000 gallons of water would be captured from here, and 11,217 tons of material would be saved from landfill from that. Any questions? Yes?
You had a picture kind of early about the aquaponics that they grow the algae in those vertical tubes.
Mm-hmm.
Are they purposely set next to that open window?
Yeah, so to give them light, yeah, so that they...
When it looked like the tubes weren't transparent, I was wondering if it
Yeah.
was heat or light or...
It's the lighting. They're transparent tubes, yeah, and they put them next to the light there so they can use the light to grow. But yeah, it was just bad lighting. It was really hard because the light was coming in the window, so it was really hard to get it right. So yeah. Any other questions? All right. Thanks for your time.